All right, for our next example, let's find the solutions to 2 cosine x equals 2 radical 2. So the first step is going to be to isolate the function. We're going to get the cosine of x by itself, and the way we do that is we're going to divide both sides by 2. So we're going to get cos x equals to radical 2 over 2. Now remember in a previous slide, I said rewrite radical 2 over 2 as 1 over radical 2. So I'm going to rewrite this as 1 over radical 2 so we can get that 1 radical 2 ratio. Determine the appropriate quadrants. So we're going to ask ourselves, in which quadrants is cosine positive? So if we write all students take calculus, cosine is positive in quadrant 1 and also in quadrant 4. Now let's put in the ratios. We know that cosine is, and remember, when you draw the angle, it's always going to be with the x-axis and the terminal side. So it's going to be like this. Now we're going to fill in the appropriate ratios. So cosine is adjacent over hypotenuse. So the adjacent is going to be 1, and the hypotenuse is going to be radical 2. Now what's missing? Well, we have two special right triangles, and if you have 1 and radical 2, the other missing side is also going to be 1. So we're going to have 1, 1, and radical 2. And then in this case, because we're going down, it'll be negative 1. So which angle is opposite of a side of 1? And opposite of 1 is going to be 45 degrees. So the value of x is going to be 45 degrees. So now our reference angle is 45 degrees. We have to find the measure of each angle in standard position. The first one's easy. We're starting at 0 and we're going up to here. That's 45 degrees. Now the second angle is a little bit more difficult. For the second angle, we're starting off at the x-axis and we're going all the way here. So here's one way to think about it. This whole thing is 360 and we're missing 45 degrees from that. So if I take 360 minus 45, that'll be 315 degrees. Okay, so once again, all I'm doing is I'm taking 360 degrees and subtracting 45. Another way to think about that is this is 90, this is 90, this is 90, that's 270. And then if this is 45, this has to be 45. So 270 plus 45 is going to be 315. So either way, you get the exact same thing. All right, so the other angle is going to be 315 degrees. We need to convert these into radians. So if I multiply this by pi over 180, if I multiply this by pi over 180 and I reduce it, I get pi over 4 and 7 pi over 4. And notice that for angles, we use a squiggly bracket to represent set notation. So this is a set of values which make this equation a true statement. So our solution set is written in these squiggly brackets. All right, for our next example, we want to have 2 sine of x plus 1 equal to 0 and 2 sine of x equals to negative radical 3. Both of these we will do in class. Now, the method we've learned here is if the ratios of sides are from a special right triangle. But what if they're not? What if our ratios do not come from special right triangles? Okay, in other words, what if our ratios are decimals, like sine of x equals to 0.79? Then what do we do? Well, some of these are going to be the same steps. Step 1, we isolate the function. So in this case, sine of x equals 0.79. That's by itself. We're good. Determine the appropriate quadrants. So we're going to ask ourselves, in which quadrants is sine positive? Because we have a positive 0.79. All students take calculus. That's going to be in quadrant 1 and quadrant 2. Okay, now here's where we're going to do things a little bit differently. So we're gonna sketch our angle in quadrant 1 and in quadrant 2. But before, to find the value of x, because these were special angles, we can just say, all right, well, what's opposite of 1? 45 degrees. What's opposite of radical 3? 60 degrees. However, in this case, because we don't have these special right triangles, we need to find a value of x using a calculator. So how do we do that? So step 3 says, take the inverse of each side. To undo sine, to solve for x, we have to take the inverse of each side. So what we have is, we have sine of x equals to 0.79. And in order to undo the sine, we got to take the inverse sine of both sides. So we are going to take the inverse sine of the left side and the inverse sine of the right side. Because the sine and inverse sine, they undo each other, and we have x by itself. On the other side, we got the inverse sine of 0.79, which you would put into a calculator. That's the only way to do this. So if you put this inverse sine of 0.79 into a calculator, you're going to get 0.910809. And we want to write this as 3 decimal places. So to the 3rd decimal place, the number after that is a 5 or higher. That'll be 0.911 in radian form. Now, before I do this, here's a really important step. Before you take the inverse of each side, put your calculator in radian mode. If you don't know how to do that, you can ask me in class. If it's a physical class, if it's a Zoom or an online class, then you'll have to YouTube it for your calculator model. But put your calculator in radian mode. If you don't, your answer will be in degrees, and it'll cause an incorrect answer or an extra step for you to convert from degrees to radians. So put your calculator in radian mode before you take the inverse of both sides. Do this yourself and make sure you get 0.911 radians. So our reference angle is going to be 0.911. Now, based on the reference angle, we have to measure the angles in standard position. Now, the one-on-one is going to be pretty easy. The first angle, we're starting here and we're going to here. That's just going to be 0.911. That's easy. And remember, this is in radians. But the other angle, we have to do a little bit of work. The other angle, we're starting at 0 and it's going up to here. So here's what we know. This is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So this whole thing is pi, but we're missing 0.911 of it. So if I take pi and subtract off 0.911, which is this angle that we're missing, because we just want the measure of the angle that I have highlighted here in purple or whatever color this is. So if I take pi and subtract off 0.911, then I'm going to get 2.231 as the measure of this angle, 2.231 radians. And I don't have to put the units in, I put them in just to remind you guys that these are radians, and so this will be your solution here. So this tells us that if you take the sine of 0.911 in radian form, you get 0.79. If you take the sine of 2.231 in radian form, you get 0.79, and you can verify that on a calculator. Okay, let's take a look at the next example. Okay, next example, we want to find the solutions to cosine of x equals to 0.51 on the interval 0, 2 pi. So first, isolate the function. It's by itself, so that's good. Determine the appropriate quadrants. So we're going to ask ourselves, in which quadrants is cosine positive? In this case, we got a positive 0.51. So we have all students take calculus, and cosine is going to be positive in quadrant 1 and also in quadrant 4. Okay, so how do you find x? Well, we take the inverse of both sides. We have cosine of x is equal to 0.51. To undo cosine, the only way to do it is to take the inverse cosine of both sides. So I take the inverse cosine of the left, and I take the inverse cosine of the right. Now, once again, make sure that your calculator is in radian mode. Super important. Make sure that your calculator is in radian mode. So that's going to cross out the cosine, and the inverse cosine crosses out the cosine. We get the x by itself, which is what we want. And the inverse cosine of 0.51 is going to be 1.035612. We want to round to 3 decimals for my open math, so the number after that is a 5 or higher, which means our reference angle is going to be 1.036. Okay, so the value of x is going to be 1.036 in each of these quadrants. Now we sketch these in quadrants 1 and 4 because that is where cosine is positive. Now we're going to measure both these angles in standard position. So the first angle is going to be easy. We're starting here. And we're going to go up to there. So x equals to 1.036 will be one angle. Now the other angle, it's a little bit harder to measure because we want to measure this angle starting from the x-axis going to here. Now here's what I know. I know the whole thing, if I make a full circle, it's equal to 2 pi. But I don't want the whole thing. I don't want I just want from purple to purple. Now I want this portion right here. So I don't want the 1.036. So if I take 2 pi, which is a full circle, and subtract off the 1.036 in my calculator, that's going to give me 5.248 radians. So the measure of this other angle is going to be 5.248 radians. All right, so the last two, we are going to work on these in class.